Okay, so today we're going to be working on our long division using the standard algorithm. So this is our story problem for today that we're going to be working with. So I'm going to read you this first. So it says, there are 343 students in a school. The teachers are trying to divide them into groups of 5. How many groups of 5 can be made, and will there be any students left over? So if you think about this problem, it's going to end up being 343 divided by 5. And so our question is, how many groups of 5 can be made? So this is an example of a measurement problem because our quotient is going to give us the number of groups. So let's start by writing this out quick. Okay. So we're going to start as a long division problem. So we have 343 divided by 5. And then on the side here, we're also going to do it with our base 10 blocks in order to solve this problem with the standard algorithm. So with our base 10 blocks over here, we have 300. So here's 100, 200, 300. And then we have 4 tens, 1, 2, 3, 4, and our 3 ones. So we have 343. And so our goal is to divide this 343 into 5 equal groups. So first we have our groups down here. So we're going to have 1, 2, 3, 4, 5. And we want to divide up our base 10 blocks into these 5 equal groups as our end product. And so our first question that we're going to ask ourselves, we're going to cover up the 4 and the 3, and we're going to be left with this 3, which is representing 300. So our first question is, can we divide this 300 evenly into 5 groups of hundreds? So if we come over here, we have 3 hundreds. Can we split these evenly into 5 groups of hundreds? The answer is no, because we only have 3 of them, and they cannot go into 5 groups. So we need to start by regrouping in order to go to the next place value. So if we cover up the 3 and we go to the next place value, we're at the 4. So this is going to represent 34 tens. So we're going to start by regrouping these hundreds into tens. So we have our hundreds up here, and we're going to regroup them down here. So each 100 is going to be 10 tens. So this one is going to be 10. 200 is going to be another 10. And our 300 is going to be another 10. So now we've used all of our hundreds and we've regrouped them into tens, and we are left with 34 tens, which is shown in our problem over here as well. So now we can group these 34 tens into our 5 groups evenly down here. So let's start by doing one at a time. So we have 1 10, and then we can get rid of it up here. Another one in our second group. 3, 4, and 5. So far we've grouped up our 5 tens, and now we have the rest of these tens left to put evenly into our 5 groups. So if we do 5 at a time, we have 1, 2, 3, 4, 5, and then we just use these 5. And then we have another 5 tens. And we're going to keep doing this until we run out of tens to group into our 5 groups down here. Okay, so then we have 1, 2, 3, 4, 5. Okay, so then now we are left with our tens from up here, in which we have 4 left. So we have 4 tens left, and we have 5 groups. So now you're going to ask yourself again, can I split these 4 tens into 5 groups evenly by using tens? And the answer is no, because you only have 4 of them, and you need 5 groups. So we're going to pause here with our tens. So let's see how many tens we were able to put into our groups. We have 1, 2, 3, 4, 5, 6 tens in each group. So that is where our answer is going to go up here as 6 tens. So we have 6 tens multiplied by 5 groups, which gives us 30 tens total that we've used so far. And we started with 34 tens, so that means we have 4 tens left. And then we already figured out, we asked ourselves we cannot split these 4 10s that are left into our 5 groups that we have here. So we're going to need to regroup again and hopefully regroup into our 43 ones by regrouping these. So let's see if we can get these 10s to regroup into 43 ones. So we're done with these hundreds up here. So each of these 10s is also going to regroup down here. So this 10 will be 5 ones, or 10 ones. And we've used that. And this is also 10 ones. Okay, so now we are left with 43 ones, as shown right here as well in our standard algorithm that we need to split up into our 5 groups. So we're going to do the same thing that we did with our 10s, starting with 1 1 in each group. So 1, 2, 3, 4, 5. That means we just used 5 of them, so we can erase those. 1, 2, 3, 4, 5. And we're going to keep doing that until we have used all of our 1s. So we're adding 1 1 into each group, and we want to make sure that all of our groups are evenly distributed. Okay, so we use those 5, and now we have these 3 left up here. So we're going to pause one more time, and can we split up these 3 1s into our 5 even groups? And once again, the answer is no, because we only have 3 1s, but we have 5 groups. So we're going to take a step back. Let's see how many 1s we were able to put into our groups. We have 1, 2, 3, 4, 5, 6, 7, 8 1s in each group. So that's our answer up here. And then we have 8 1s multiplied by 5 groups gives us 40 1s. And we started with 43 1s, and we've used 40. So 43 take away 40 is 3. So now we're at the same point in both places. We're left with our 3 1s. And so these 3 1s, since they cannot be distributed into our 5 groups, are going to be our remainder, which we will also write up here. So we have 3 1s left over because they cannot be evenly distributed into our 5 groups, and we've already regrouped them down to 1s, and they can't be regrouped again. So our final answer is going to be 343 divided by 5 equals 68, remainder 3. And so with our story problem that we've had at the beginning, what is this answer going to represent? So it's going to represent, we have 68 groups of students with 5 in each group. And then our second question, are there any students left over that are not in the group? And the answer is right here. We have 3 students left over without a group. So we have 5 represents the number in each group. And our 68 represents the number of groups. And that is how we get our measurement problem here, because our quotient is the number of groups. So our answer is 68, remainder 3.